Hello Enforce, today I'm going to be assisting you with maths and we're going to be focusing on differentiation. So from N3 we learned about using the first principle to get the derivatives and then also learned about the derivative laws. So from first principle, if you are given a function, say y equals to 1 over x plus 3 and then they say find the derivative of that function. The formula says that f prime x is given by what? By f of x plus h minus fx all over h, but we are taking what? The limit as h approaches 0 of that. Yeah? Okay, sharp. So now here we can say this is the same as what? As a function in terms of x, right? Okay, sharp. So if that is the case, it means it's the same as that f of x. So we are looking for what? F of x plus h. So f of x plus h will be what? F of x plus h equals to, we substitute x plus h in everywhere where you see what? We see x. So this is going to be 1 over x plus h plus 3. And this gives us 1 over x plus h plus 3. Okay, sharp. So now we substitute everything back into what? Our first principle. So it's going to be what? Therefore, f prime x equals to limit as h approaches 0. What is fx plus h? We solved it here. So we just substitute it here. So it's going to be 1 over x plus h plus 3. And then minus, we substitute what? Fx. So fx is the initial function. So it's going to be 1 over x plus 3. And then everything is divided by h. So there's no way, it's either I can divide each and every term by h, but there's no way again I can multiply with the h without making this one term. Ne? So for me to do that, I need to what? I need to look for the LCM. So I'm going to look for the LCM at the top. So this becomes what? F prime x equals to the limit as h approaches 0. And then everything, remember, is divided by what? By h. So here at the top, I'm going to look for the what? For the LCM. So the LCM will be what? X plus h plus 3 multiplied by x plus 3. So it's going to be what? X plus h plus 3 multiplied by x plus 3. And then I come here and say, okay, this divided by this, it's going to be what? I'm going to be left with x plus 3. Multiplied by 1, it gives me what? X plus 3. And then minus this divided by what? X plus 3, it gives me how much? X plus h plus 3. Multiplied by 1 is that. Ne? Okay, sharp. So now this becomes limit as h approaches 0. Remember, everything's still divided by h. And I need to what? I need to multiply out the brackets at like terms and then see how I can manipulate my equation there. So this becomes x plus h plus 3, x plus 3, and then from there this becomes x plus 3 minus x minus h minus 3. So now this is the same as just having a bracket there at the end, right? So it means I can what? I can turn the h around and then this becomes what? Okay, let me just remove, okay, or I can multiply, okay, let me just do this. This becomes limit as h approaches 0. This is the same as x minus x, it's going to be what? It's going to be 0, right? So this will cancel this. Then 3 minus 3, this will cancel that. I'm going to be left with what? With minus h. All over, this is the same as x plus h plus 3, x plus 3. And then remember, when you divide by h, I'm just going to write it here, divide by h, but it's the same as multiplying by what? 1 over h. So I'm going to remove this. I'm just going to say it's multiplied by what? 1 over h. Let me just do this so that I don't get confused. Okay, sharp. So now this becomes what? Limit as h approaches 0. And then I see that this h and this h will do what? They will cancel, right? So I'm going to be left with what? Minus 1 all over x plus h plus 3, x plus 3. So in the place of h now, I can substitute what? The value of what? of h. So this becomes minus 1 all over x plus 3, x plus 3, which is the same as minus 1 over x plus 3 squared. Then you are done. You get your free marks. So now, after learning about the first principle, also learned about the power rule or the derivative laws. So the power rule just says if you have fx given as x to the power of n, if you were to differentiate that, you'll have what? F prime x, which is going to be what? You transpose the n down. This becomes x and x and minus 1. You get that. So let's just say now you're given something like fx equals to 2x squared, and then you had to differentiate that. You get what? You keep the constant 2, you transpose the 2, you get 2, and then this becomes 2 minus 1. You get something like that. So this gives you 4 to the power of x. Okay, sharp. So we learned this, but this can be given in terms of what? Of a polynomial. Maybe you can get something like fx equals to 2x cubed plus 3x plus pi x, something like that. Yeah? So remember, guys, pi is what? It's a number. So you must treat it the same as 3 and all the other numbers, right? So this is the same. So if you were to derive this, you're going to get something like this. F prime x equals to 6x squared plus 3 plus pi. So this actually can group it as just being one number, or you can get the actual value of pi. Okay, sharp. And then from there, now in N4, we are doing the big guns now. Ne? So we're going to learn about the product rule, the quotient rule, and the chain rule. So let's differentiate between between the three rules. So the first one is what? It's the product rule. So a product rule, it talks about functions that are being multiplied. A product is a multiplication of two things, right? So in this case, we are talking about function x being multiplied by function gx. Yeah? So if you have, let me just say, if you have f, which is big F, and is given by what? By fx multiplied by gx, this can be written as what? The derivative of this big F can be given by f prime x, and then you keep that gx, plus, now because we differentiate this one, and then we kept this one, we differentiate this one. So you're going to get gx, and then you keep this one, fx. Example, if you are given something like fx equals to 2x multiplied by, let me just say sine x. So you can see I'm multiplying 2 to the power of, sorry. This is 2x, not 2 to the power of x. 2x multiplied by sine x. Ne? I'm multiplying 2x and sine x. Both of them, they are functions of what? Of x. Ne? So if I were to find the f prime x of this, according to the product rule, I have to what? Factorize, differentiate this one first. So it's going to give me the derivative of 2x is how much? Is 2. Then I keep this one. It becomes sine x. I take it as it is. And then I say plus. Now I keep this one. I differentiate this one. So when I differentiate that, it gives me minus. The derivative of sine is cos, minus cos x is minus cos x. Then this one, I keep it as it is. Gives me 2x. We're clear on that, right? And then this gives me 2 sine x. This gives me minus 2x cos x. And then this is what? Is the derivative of fx using the product rule. We can also use what we call the quotient rule. So using the quotient rule, remember when you have something like fx equals to 2x squared minus x, maybe divided by x. In N3, you could have just divided each and every term at the top with this x. But there is another method, for in case if you get something like x minus 1. Even if you divide by this x minus 1 each and every term, you're going to get something like 2x squared minus 2x squared over x minus 1 minus x over x minus 1. It's still difficult to differentiate that, right? Rather, forget about this and focus on what we call the quotient rule. So the quotient rule states like this. If you have a big function whereby you have fx over gx. So this function is given by when you divide fx with gx. How are you going to get the derivative of that? And then from there, the rule says that if you have a function like that, you can differentiate it as follows. Fx equals to, you differentiate at the top. So it's going to be f prime x multiplied by, you keep the one at the bottom. So it's going to be gx minus, I differentiate now the one at the bottom. So it's going to be g prime x. And I keep the one at the top. So it's going to be what? Fx. And then divided by, so the rule says I must divide by the gx squared. So yeah, all of this is there in the formula sheet. If you get something like this, you just follow it and you substitute your values there. So the first thing that you're looking for is the derivative of fx. So fx is what? It's the one at the top. So you're going to what? Derive there at the top. So the derivative of 2x squared minus x is going to be what? So the derivative of 2x is going to be 4x, then minus 1. And then I keep the one at the bottom. The one at the bottom is what? X minus 1. So x minus 1 minus, and I derive at the bottom. The derivative of x minus 1 is how much? It's going to give me 1, and that one of the constant falls away. Ne? So it's going to be 1, and then I keep the one at the top, which is this. It's going to be what? 2x squared minus x. So 1 times this is the same as having that bracket as it is, right? And then divided by what? Divided by gx is what? It's the one at the bottom. So it's going to be x minus 1. But they say we must what? We must square it. This is according to this formula there. And then from there you get what? You just multiply out. So this becomes 4x squared minus 4x, and then minus x plus 1. And then you multiply the negative inside the bracket. This becomes minus 2x squared plus x, and then everything divided by. So that one is going to give us, multiply out the square of 2. Ne? So it's going to give us x squared minus 2x plus 1. Makes sense, ne? Okay, sharp. So let's see. After here, you look for like terms. And then, let me just erase here. So this is going to be what? I see I have something with x squared here. I have something with x squared here. So 4 minus 2 is going to give me how much? 2x squared. And then another like term is this one of x, and this one of x, and this one of x. So this gives me minus 5x plus 1. So it's going to be what? Minus 4x. Or you could have just cancelled this and this. So are there any like terms at the top? No more like terms. At the bottom, you're left with what? You're left with x squared minus 2x plus 1. This is equals to your what? F prime of x. So yeah, you can leave your answer like that. So now we know how to use the product, the quotient rule. So we need to look at what? At the chain rule. So chain rule, we saw that this one is, we saw that the product rule is when you multiply two functions. And we saw that a quotient rule, it's when you divide a function from another function. Ne? So now, a chain rule, it's what? A chain rule, it's when you have a function inside a function. A function that is composed of another function inside it. Okay, sharp. So now, let's just look at a simple function like fx equals to cos 2x. f, it's a function of cos, né? But inside cos, there's another function called 2x. Can you see that? So if you let u equals to 2x, you can rewrite this as f. Okay, let me just do this. You can have this. The derivative of y in terms of x, you can rewrite this by multiplying by du over du, which is 1, right? If you rewrite that, it can be what? dy over du over dx. This and this, when they cancel, it still takes you back to what? To this here. Okay, sharp. So now, the derivative of, if you substitute u in terms, in this place, you're going to get f u equals to cos tu, and then the derivative of this in terms of u, you're going to get what? Minus sine t, what did I do? Sorry, this is going to be u, not 2u. So it's going to be u, so you're going to have what? Sine u. Okay, sharp. And then from there, you just come here. Okay, what is the derivative of y in terms of u? This is the derivative of y in terms of u. So dy over du. You just substitute here, you get what? Minus sine u multiplied by derivative of u in terms of x. This is u. It's going to be what? The derivative of this one. So du over dx is going to be what? Derivative of 2x is what? Is 2. So 2. So at the end, you get what? Minus 2 sine u. But what is your value for u? It's what? It's 2x. You go back, you substitute your value of u. So this becomes minus 2 sine of 2x. All right. Or another way of noting the chain rule, guys, you could just do this. If you have a big function, and then you have f of g of x. I don't know if it makes sense, but yeah. If you have f of g, because like gx is inside of what? Of f, né? So you have a function inside of a function. So how you do this? You'd first derive the outer function. So you're going to get f prime, but in terms of what? Of gx. And then after that, you go inside the function. You have to also derive this one. So multiply by g prime x. So you can use this if they don't tell you, follow the steps. You can use this formula here, that f prime of x equals to this, or you can just follow the formula if you're comfortable with this one. Okay. So now we know all the rules. We just have to add on some important things. When I was doing the sums here, like you saw, I was deriving things like sine and cos, but I was just naming them and didn't know where they come from. So now I just want to make sure that you guys are comfortable with this. I'm going to give you some of these derivations and where they come from. So, okay. We're going to look at trig functions. Trig functions, né? But everything is given there. So if you look at your formula sheet, all these formulas to help you derive these trig functions are given. So according to this, you have what? The derivative in terms of x of sine x is given by what? By cos x. And then the derivative in terms of x of cos x is given by what? It's given by minus sine x. And then the derivative in terms of x of tan x is given by what? It's given by sec squared x, and so forth. So you need to know these things. So, and then the one for cot, it's minus cosec squared. And then the one for sec is sec x tan x. And then the one for cosec, it's minus cosec cot x. And then you also have your log functions and your natural exponent function, exponential functions. So you need to know also that the derivative in terms of x of ex doesn't change. It is also given as what? As ex. So the derivative of ex is also ex. And also the derivative in terms of x of ln x. Remember, ln x is the same as what, guys? It's the same as log base ex is given by what? It's given by 1 over x. Yeah? And then another one that you need to know is when you're given a x, where a is any number. If you have to derive this in terms of x, it will give you ax ln of a. So you need to know these things, especially when you start doing these big problems in your tests and in your exams. So let's look at a past paper and see what they have here. So I have y equals to the square root of 5x plus 1. And then they say using the chain rule function, differentiate that function there. So it's fine. So guys, when you have a square root, you know the square root is the same as what? To the power of 1 over 2, right? So it's up to you if you want to rewrite this as 5x plus 1 to the power of 1 over 2, right? So y equals to that. So they say differentiate that using the chain rule. So you can see that you have this big function to the power of half, and inside that something to the power of half, there's something going on in there. So you're gonna use what? The chain rule. You can say what? Let u equals to 5x plus 1. So if you do that, this becomes y equals to u to the half. So if you differentiate this in terms of what? So the chain rule says dy over dx equals to dy over du over dx. So let's differentiate this dy in terms of u. So dy over du gives me what? Half u. Then half minus 1 becomes what? Half minus 1 is the same as half u is minus half. Ne? So then now you differentiate u in terms of x. So you look for du dx. What is du dx? So this is du, right? So you're going to look for du over dx. We get how much? We get 5. The derivative of a constant is 0, right? So you're left with what? 5x. So this is 5x. And then what you do, you just substitute back in your equation. So dy over dx equals to dy du. Dy du is what? It's half u minus half. And then du dx, it's 5x times 5x. But the value of u, we know it from here. It's what? It's x. It's 5x plus 1. So you just substitute in the value of u. So this becomes half of 5x plus 1 to the power of minus half times 5x. Guys, always remember to avoid having negative powers. So we want to write this as a positive half. So how are we going to do that? We're going to take it to the bottom of the equation. So it's going to be what? Therefore, I'm just going to do this here. Therefore, dy over dx equals to, this is going to be 5x all over 2 times 5x plus 1, everything to the power of what? It's positive now because we took it to the bottom. Ne? And then now, this is going to be what? The same as 5x all over 2 square root of what? Of 5x plus 1. Easy stuff, ne? Okay, sharp. So now we can move on to another problem where we have y equals to ln x to the 3 over ln x. So this, you can say we're going to need a quotient rule. And then also we're going to need what? A chain rule, because we have a function and there's another function inside the function. So let's first start. What is the derivative of ln x? It's going to be x cubed. It's going to be 1 over x to the 3. Multiply by, we go inside the function. What is the derivative of x to the 3? It's equals to 3x squared. And then after that, we keep the one at the bottom according to the chain rule. Let me just do this. So it's going to be ln x and then minus. I derive at the bottom. I get what? 1 over x. And then I keep the one at the top. It's going to be what? ln x to the 3. Then I divide everything by what? By ln x, and I square it. This is the chain rule, guys. And I mean, this is the quotient rule. Then from there, I just multiply out. This at the bottom gives me 3x squared all over x to the 3 multiplied by ln x minus ln x to the 3 all over x. Everything divided by, I'm just going to leave it at ln x squared. So you can see that this and this will cancel each other. You are left with what? With 3 over x multiplied by ln x, and then minus ln x to the 3 all over x divided by ln x squared. Let's see how much was that for, so that we can know whether we leave it here or we have to. So it was out of 4 marks. I'm suspecting that you can leave it here. It's fine. Other than that, you're gonna first look for what? For the LCM of x. So it's gonna be what? It's gonna be x over. So x divided by, this is the same as this. Okay. Oh, sorry. So this is the same as. Let me do this. This is the same as 3 ln x over x minus ln x to the 3 over x all over ln x squared. So the LCM value is what? Is x over 3 ln x minus ln x to the 3, then everything divided by ln x squared. So I divide by ln, so this becomes 3 ln x minus ln x to the 3 all over x multiplied by 1 over ln x squared. Remember, when you divide by this, it's the same as multiplied by 1 over. Then this becomes what? 3 ln x minus ln x to the 3 all over x ln x squared. Well, that's it, guys, for today. We're going to continue again next time. Probably we're going to do a problem that involves the turning point and drawing of the graph. Thank you, guys, for watching. Please, if you have any questions, guys, you can look for me on Facebook, Ampule Makara, or you can hit us on our social platform at Nkangala TVET College, and we'll be able to assist you with further questions. Thank you.